What's good, math family? In today's video, I'm going to show you 3 key tips to solve any absolute value equation. And at the end, we're going to talk about extraneous solutions and why they're important. Starting this video out, rule 1, have to isolate the absolute value. So when we look at our first example, this is not isolated. It has a +1. So we're going to subtract 1 on both sides, and we'll have the absolute value of 2x minus 4 is equal to 10. Now that the absolute value is isolated, we can move to step 2, which is create and solve. So we know we're going to create 2 equations and we're going to solve. So the first equation stays the same. Absolute value of 2x minus 4 is equal to 10. Now we drop our brackets and solve like a regular equation. So I add 4 on both sides. 2x is equal to 14. We divide to get x by itself. We know it's equal to 7. So that's our first answer choice. Now, equation number 2 is the same exact thing. Absolute value of 2x minus 4 is equal to not positive 10, family, negative 10. So now at this step, drop our brackets, add 4 on both sides. We have 2x is equal to negative 6. And after we divide, we get x is equal to negative 3. Now we've done steps 1 and 2. Now step 3, this is when the extraneous solutions come in, because sometimes one of these answers may not solve the equation or make it a true statement, meaning left side equals right side when we plug it back in. And when we plug it in, we're plugging it back into the original absolute value equation. So let's start off with 7, right? And let's switch colors so this pops out more. So we have the absolute value of 2 times 7 minus 4 plus 1 is equal to 11. We go inside and simplify. We have 14 minus 4 plus 1 is equal to 11. Still inside the absolute value bracket because we didn't simplify it completely. So we have the absolute value of 10 plus 1 is equal to 11. Comes out the brackets. It's going to stay positive because it's already positive. 11 is equal to 11. We know that this is a solution, right? And it satisfies the equation. Now, when we go over to here, put a little line to separate it. We'll repeat the steps. So the absolute value of 2 times negative 3 minus 4 plus 1 is equal to 11. So I focus inside absolute value brackets. We have negative 6 minus 4 plus 1 is equal to 11. Still inside the brackets, I simplify to get the absolute value of negative 10 plus 1 is equal to 11. Now, when we drop the brackets, this is when the absolute value, whether it is negative or positive, is going to become positive. So now this negative 10 becomes positive, and 10 plus 1 gives me 11, which is equal to 11. So after solving this first absolute value equation, we know the solution set x is equal to negative 3, 7, and we know there are no extraneous solutions to that. So now we're going to go over to our second example, and let's get some more space. And the second example is a little bit tricky at times because students aren't always used to having variables on both sides of absolute value, but it's the same rules. So when we go in, step 1, isolate. Absolute value is already by itself, so we don't need to do anything. So when we look at this, this is the equation we're going to solve for the first step. So our first equation, absolute value of x plus 4 is equal to 3x plus 2. I drop my brackets and I solve like a regular equation. So I'm going to subtract x on both sides. We have 4 is equal to 2x plus 2. After I subtract 2 on both sides, I'm going to get 2 is equal to 2x. And after we divide, we know that x is equal to 1. So that is our first answer choice. Now when we go over to our second answer choice now, right? Or second equation, I should say, not answer choice. We didn't get there yet. what we're going to do is absolute value of x plus 4 remains the same. But now this right side changes, we make it negative. So what I like to tell students, if there's more than one term like this, put it in parentheses and put a negative sign in front because we are going to distribute it to the entire side or the entire expression. So now this becomes the absolute value of x plus 4 is equal to negative 3x minus 2. A lot of times I see students will just make the first term negative. This is why you may get it wrong. So now we go back, drop our brackets, and we're solving like a regular equation. So I go through, I'm going to subtract x again, right? So we have 4 is equal to negative 4x minus 2. Now we add 2 on both sides to get 4x by itself. Now I have 6 is equal to 4x. Let's not forget our negative sign. So we go through and divide to get x by itself. Now we have, and I'm going to divide this fraction by 2. So we have negative 3 over 2 is equal to x. And I'm going to tell you guys, when you have something like this, let's just be reminded that this is the same thing as saying x is equal to negative 1.5. And this is just easier for us when we plug it back in to solve. So just trust your boy on this. All right. So we're going to go back over to this left side and let's go in black. And we're going to see if any of these are actual solutions. So let's check with 1. So now we know, erase some space, man. This looks a little sloppy. All right. So now we know we have the absolute value of 1 plus 4 is equal to 3 times 1 plus 2. So when I simplify, right, we know this is just the absolute value of 5. And then 3 plus 2, right, we know that's just going to be 5 is equal to 5. That is a true statement, right? So this is indeed a solution to the absolute value. It's not an extraneous solution. Now, when I go back in and I substitute in negative 1.5, let's do it. So now you have the absolute value of negative 1.5 plus 4 is equal to 3 times negative 1.5 plus 2. Oops, I knew something looked right. All right, so now we go through. When we look here, this is going to be the absolute value of 2.5. And when we multiply, let's see, 3 times 5 is 15 plus 1. All right, so this is negative 4.5 plus 2 on the right side. So now I simplify. This is going to come out the absolute value bracket. It's 2.5. And we're saying that's equal to this, which is going to be negative 2.5. So when we look at this last answer, we should know that this is not a true statement. 2.5 does not equal to negative 2.5. So as a result, we know when x is negative 1.5, that is an extraneous solution, meaning the only solution for this absolute value equation is x is equal to 1. Really hope this review on absolute value equations and extraneous solutions was helpful for your family and quick. If it was, smash the like button for us, subscribe to our channel, and leave comments down below if you have questions on this video or if there's topics you'd like to see on our channel in the future. Thank you guys so much for continuing to watch and support Algebra 1 with Mr. Peters.